Good morning, YouTube. It is Friday, November 10th. This morning we've got a two-system fall maintenance checkup for a customer that has been with me for a while. And I'm not sure how video worthy it'll end up being, but we'll at least record this section and see what happens. So we'll catch you on in a little bit.
HVAC with Stephen Rardon is sponsored by TruTech Tools. Quality tools, essential support. TruTechTools.com.
Upstairs we've got the patient here, a RHLL HM2417JA Rheem air handler, and customer stated that the blower motor has been replaced by another company because it had failed. It was under warranty, so not a massive expense, but since the motor's been changed, I want to double check and see if we need to make sure that the blower speed tap is correct. I can't imagine that they would have changed it, but I would imagine they went back for exactly what it was, but I just wanted to double check my wiring down here, and we'll check the electrical lugs here, make sure those are tight. Thankfully, we've got copper wire instead of aluminum. That one was pretty. That one is loose, or aluminum. So I'm gonna have to dig through the paperwork again to see if I can confirm my blower performance. Otherwise, static pressure doesn't mean anything if I don't know what the blower performance should be. So, I think there should be some marking in here to show where the blower was previously. Data, that's not blower data. There's something about airflow. Doesn't say static pressure at airflow. There we go. We've got a 2417 with a heater kit. It's not a 13 kilowatt kit, but with a heater kit, that's where we're going to want to be checking our static. So, we'll see if we can fire this up and see what the static is. Probably my least favorite thing about this air handler design is the fact that it doesn't make checking blower performance very easy, because you have to pull that disconnect handle out of the door to take the door off. But we'll see what we get here. I've got the power at the condenser turned off, so we can operate the system without worrying about Now we got a 5-minute delay. The motor's been running for a little while, and we're at 0.43. If we look at the page, it indicates that at 0.5 on high speed, we're running 838 CFM. So, since we're 0.43, we're going to call it 0.5, and we'll say that our airflow is fine. I'm going to jump down and get some other readings from outside. The customer also stated that when the summertime check was done, they washed the coil on the outside, but they didn't bother to remove the minimal amount of pine straw and stuff inside here. Told him it was not a problem. I was going to pop the top anyway to get this little bit of junk out. So there's that. I can't read that capacitor anymore. It's been baked. Get set up with my pipe clamps here. I think I'm going to use this one since I need to run through, get discharge as well as common suction. I think I had to pull the service panel to get that wire out of the cabinet. Yeah, I gotta come through the compressor wiring port. Getting a little bit of a buzz on that contactor. Common suction, and then we got discharge temperature. We're going to be taking head pressure. All right. screw doesn't hold down quite like it used to. It's really disappointing to see the lack of quality in equipment these days. This condenser is a 15 PJL 24A01. Common section there. We'll get head pressure. I'm going to play with liquid line port. That could be fun. There we go. Wasn't as bad as I thought it might be. Got one more clamp for the subcooling. Check that capacitor. Once we're up and running, first thing we're going to tie into is condenser fan motor, which is hiding down here. There it is. We're going to check amp draw on the condenser fan. Power up. We're taking temperature split without the heat strips. And I put the attic door back on so that we wouldn't pull any cold air from the attic unnecessarily. It is a pain in the butt to try to get these capacitors checked, but if you're careful, you can do it. So condenser fan motor is running at 0.69, rated at 0.6. The compressor capacitor is 40 and 5. I'm going to take amps off of the capacitor fan side here and then calculate amps. Or calculate microfarad. 2652 times 0.63 divided by 344. 4.85 out of 5. So we're okay there. Check the compressor side. I think that's the purple. Yeah. The purple wire going to the compressor from the capacitor. That one is reading 4.75 amps. So 2652 times 4.73 divided by 343.5, 3652. That one's a little out of range. Our superheat is kind of low, considering we're on a TXV. It's coming up though. Subcooling's about where I want to see it. Return 67.6, supply 82. If we look at system performance, target temperature split's 29 degrees for heating. Right now we're at 14.8. I'm gonna go ahead and hold on. I screwed up the condenser compressor capacitor calculation. I used the same volts with the amps, so let's make sure we get that correct. 2652 times 4.73 divided by 340. We're at 3689. And if I jump back to the mechanical inspection, $36.52 to $36.89, we're not that far off between the two, still out of range by a little bit. What I was going to do was get some voltage measurements before I realized that I screwed up that capacitor calculation. I was going to get voltage for the condenser, and we've got 122.1 and 122.5. 122.1 and 122.5. See if we can clamp on that wire. 122.1 and 122.5. We're gonna let it balance out before we take the amp draw. We're getting a 17.6 degree split, so we still got some heating to do. While we're waiting on that, I'm gonna go ahead and grab my, oh, it balanced out, but we're shy. We're shy on the temperature split, but it says we're balanced up there with the green check mark. A good bit shy on the temperature split. Could be probe location, maybe. 69.6 and 88 supply. The fan speed is set for factory. I'm going to let it run for a while. Go check the second floor for thermal. We got the Fluke TIS 75. Turn that on. I'm going to see if I can get my Fluke Connect to work. I haven't tied it in yet. Go look for Fluke camera on my Wi-Fi list. I think I've got Wi-Fi turned off. Nope. It's there. Fluke camera. It looks like we're connected. Connected to the Fluke Connect. Thermal camera. And now I'm seeing, with a minor delay, I'm seeing what my camera is seeing on my phone. Ooh. I think we just went into defrost. Yeah. Maybe? Well, I'm gonna let it run anyway. like we've got pretty good insulation actually. Got some heat with the smoke alarm. You can see the heat on the window from the register. That's what I feel like. This is fun to me. Let's turn the light off in the hallway. See if that'll help a little bit. The attic door is obviously a leakage point. Got a lot of sun coming through the window. Alright. See what the downstairs unit is doing here in a little bit. Alright. So input electrical amps 7.7 on the condenser. See if we can get that other wire. There we go. That one's 7.9. It's coming down a little bit. 7.9. So there we go. COP is 3.4. We're getting about 1.5 tons at 51 degrees outside. The system went into defrost already, so I'm not worried about it going into defrost while I'm playing with it. We can go ahead and shut it down so that we can get our clamps and stuff out of it, and we'll move on to that unit over there. Downstairs, this crawl space looks a lot nicer than it did last time I was here. A lot nicer. I need to make sure that my auxiliary heat doesn't come on. Got the thermostat turned on already. So we're gonna do that, and then get ready for static. This one hasn't been fiddled with, so I'm not worried about confirming the blower chart at this point. Enjoy laying on my belly, trying to reach and work. It's such an enjoyable practice. Let's see what we got here. This one is running a 0.576, 0.57 TESP. It's the same air handler, so we're running a little bit higher, which is slightly reduced airflow. But from what I remember of that blower chart, it's not ridiculous. See, I'm laying on my side and I can't even see my meter. Can't even see my meter. It's pretty frustrating. This one's running 1.8 1.5 amps. 1.5 amps. Let's see if we can get voltage on this sucker. 123.2. 123.6. 1.45. So static 0.567 or 0.57. We're gonna go fire up the condenser and see how she's doing. So I fired up the condenser and immediately started whacking the top of my clamp. So I'm gonna see if I can find a better place to put it that's not as high. I'm amazed how close some of these manufacturers build their units where the fan could come into contact. I mean, that is ridiculously close to the condenser fan motor. Anyway, let's try that again. Alright, no whack-a-mole. I am going to call up the manufacturer and see what we get on potential for additional warranty on this condenser fan as it's leaking oil. Well, we just balanced out. We've got a 23-degree temperature split, getting 2 tons of capacity out of the system, and let's see if we can check that capacitor and the fan motor. This one is reading 0.91 on the fan motor, and it is out of range on the 0.6. Let's get that capacitor. See if we can get our fat fingers in there. There's our fan wire. See if we can get to common. Fan for amps. So we got a 0.6 amp draw on the capacitor lead and 321 volts. 2652 times 0.6 divided by 321, 495. Move over to the compressor side, which is a 40. Let's see if we can get that compressor wire out of that bundle. That's 4.9 amps. 2652 times 4.92 divided by 336.9. 3873. So we're doing pretty good there. We'll get electrical for the condenser. We've got 120.8 and 120.7, and the amp draw is 7.24, 7.25, and 7.25. 7.25 and 7.67. COP is coming out at 3.71. Refrigerant charge looks pretty good. Temperature split's not far from where we want it to be. We'll finish up that report. It looks like the last report I made was 11/11/16, so 1 year to the day, or 1 day short of a year was when I was here last doing a heat check. So we're staying right on schedule. Here I've got a new 40x5 capacitor, January 4th, 2016, and then a new outdoor fan motor, 11/11/16. I'm pretty satisfied with that. I'm going to clean up my junk and we'll go from there. Shout out to the fan man. He's in here talking about insulation and air sealing with my customer, and being that I'm fairly new to the game and I hadn't told my customer that I am offering air sealing and home performance features, he had looked for someone before I was on my own. So, but the fan man does good work. He's worked with a lot of contractors locally, and fills a very necessary niche market for attic ventilation and air sealing and that sort of thing. I guess it doesn't hurt to tell you that I'm heading up to New Jersey next week to go to the air stage Fujitsu training. Had a very good opportunity to get that training for a great deal, and so I'm excited to get a chance to go check out the air stage training for Fujitsu and expand my knowledge and capabilities. It's what it's all about. If anything else pops up today, I'll hit record. Until then, thanks for watching. Like, subscribe, comment, and share, and we'll see you on the next video. Peace.